All right, so today we are going to look at inverse trig functions, or unsign it, like the conversation we had a minute ago. So let's talk about inverses in general. So in general, not necessarily trig, a function has an inverse if and only if it's a one-to-one function. So let's remember what a one-to-one function is. One-to-one function, well, a function has to pass the vertical line test. A one-to-one function has to pass the vertical and the horizontal line test. So are there any trig functions that we've graphed so far that would pass the horizontal line test that you can think of? They all fail them pretty miserably, right? So as they are, they're not going to have inverses. Okay, so it says this means it must pass the horizontal line test. However, if the domain is restricted, which is what we're going to do, to a certain interval, the sine, cosine, and tangent functions have inverse functions. Okay? So then it says when graphed on a restricted interval, the inverse of the sine function is the arc sine. So to abbreviate that, that is ARC SIN. That is the exact same thing as sine inverse or inverse sine. It's just a different way to say it. Okay, and then the inverse. So then the inverse of cosine is the arc cosine, abbreviated ARC COS, or cosine inverse. And then the inverse of tangent is the arc tangent, so ARC TAN, or tangent inverse. So they mean the exact same thing, just depends on where you see it and who says it and whatever. There's one's not better than the other. So we're going to look at these from a graphical standpoint. We're not going to be graphing the inverses any more than what we do on the notes today, but just so that you can hopefully wrap your mind around the domain and range of these things in general, like what your input or output is for the actual questions that's being asked. So let's start with arc sine. So for arc sine, we would be ARC SIN or sine inverse. So we're going to graph over here. We're going to sketch negative 2 pi to 2 pi of sine, just so we can have something to talk through with this. So it looks something like that, and then keep going. So as it is, passes the vertical line test, does not pass the horizontal line test. So we have to figure out where our restricted domain is going to come from. So if I start at 0, okay, and I start tracing my graph, my y values are increasing till they get to 1, right? And then when they start to decrease, I'm going to start repeating those y values, and that's what causes it to fail the horizontal line test. Excuse me. So I can't go any farther to the right. I can't go past pi halves without it starting to repeat my y values. If I start going backwards on my graph, I'm not repeating any y values yet. I get down here to negative 1, and then if I keep going backwards, I'm going to start repeating my y values. So this is negative pi halves. So this little S-looking thing right here, that's the only part of the graph I get to use, because if I go any farther in either direction, I start to repeat those values, and I would fail the horizontal line test. Does that make sense to you? So that's why our domain is restricted for us from negative pi halves to pi halves. So if I graph this, when the angle is negative pi halves, sine is negative 1. When the angle is 0, the sine is 0. When the angle is pi halves, the sine is 1. So this is just one little section of the sine function. Okay, same old sine function we've been doing, nothing different there except we're just having a very, very small part of it. Domain here, they restricted for me. It's from negative pi halves to pi halves. The range is from negative 1 to 1, just like it is on the whole sine function. Okay. So when we find the inverse of a function. So now we're going to do the inverse of sine. Graphically, the inverse is just a reflection in the line y equals x. Algebraically, we exchange x and y. And when we exchange x and y, that means we also exchange the domain and range. So before I ever even graph it, I know that for the inverse function, the domain has to be -1 to 1, and the range has to be -pi-halves to pi-halves. So if you think about what that means here I'm saying, what is the sine of pi thirds? What is the sine of pi sixths? What is the sine of pi halves? What is the sine of 0? Anything between -pi-halves and pi-halves. And all of the outputs, all of those answers have to be somewhere between -1 and 1. Okay? That's how we've been looking at things. We're going to look at it backwards. Instead, I'm going to say, when is sine square root of 3 over 2? When is sine 1/2? When is sine all this stuff? And then your outputs can only be between -pi-halves and pi-halves. And that's the tricky part here. In general, what we're doing is not that complicated. But knowing what you're limited to for answers is the part that you have to make sure you can wrap your mind around. Okay? But let's go ahead and graph this. So if I said, all right, when is sine -1? So picture the unit circle, because it's a different graph than this, so sometimes it helps not to stare at this, like close your eyes or draw a little circle or something. But when is sine -1? -pi-halves. Now, you might think when you're looking at the unit circle, you might be thinking, well, that's at 3 pi-halves. And it's fine to think about it that way, but 3 pi-halves on this graph is like over here. And I don't get to graph anything over here. So since when I'm on the unit circle, right, and this is where sine is -1, I can get there by going -pi-halves, +3 pi-halves. I get to the exact same spot. The deal is now, all I get to say is -pi-halves because that's what falls in my range. So it matters what you call it. There's an infinite amount of ways to get to this spot on the unit circle. Would you agree with that? Like I could rotate a few times, I could go forwards, I could go backwards, I could do all kinds of things and end up right there. But the only answer I get to actually give as my output has to be between -pi-halves and pi-halves, so the only acceptable answer is -pi-halves. It's the only one that fits on the graph. Okay? And that won't be as complicated as it sounds right now. Just know that you have to make sure that you're thinking about the correct values. All right, so then we say, well, when is sine 0? Sine is 0 at 0. And when is sine 1? Sine is 1 at pi-halves. So it kind of looks like we did the same 3 points, but remember it's a reflection and it curves the opposite direction. So on these graphs, yes, we have quadrants 1, 2, 3, and 4 because it's still a graph. But we don't really talk about these quadrants so much as we do the quadrants in the unit circle. So when we're talking unit circle quadrants, -pi-halves to pi-halves, my positive values are coming from quadrant 1. My negative values are coming from quadrant 4. These are the 2 quadrants we're using for sine inverse. Okay? These quadrants don't match these quadrants, and it's fine. And you know, I hesitate about whether or not to even show you these graphs because I don't want them to confuse anything because we're not going to use them a whole lot. But I do want you to see how the domain and range switch places and why we only get to choose this. And even though, yes, -3 pi-halves would get me to the same spot, when you're graphing it out like this, -3 pi-halves is actually like way down here at my graph. I'm sorry, +3 pi-halves, sorry. It's actually down here and I don't get to actually graph that. It has to be a -pi-halves right here. Okay, we good so far? All right, so let's look at cosine. I've got arc cosine. This is cosine inverse. And then we're going to do the same thing. We're going to graph from -2 pi to 2 pi just so that we have a full cosine graph to look at. And that's not beautiful, but it'll work. So if I start, this clearly fails the horizontal line test. But if I start here, I'm going to start tracing my graph. Once I get here, I'm not repeating y values yet until I get to right here. Then if I keep going, I'm going to start repeating y values and I will fail my horizontal line test. So this takes me from 0 and this is at pi. So that's why my domain is restricted from 0 to pi. I'm not going on the negative side for cosine. So my domain, 0 to pi, that's my input for what we've kind of questions we've been dealing with. My range is still -1 to 1, just like it was for sine. So when the angle is 0, cosine is 1. When the angle is pi halves, cosine is 0. And when the angle is pi, cosine is -1. So it's just this part of the graph, just like it was right here. We switch places for domain and range. So the domain is now -1 to 1. That's my input. My output is from 0 to pi. So when I go to graph this, I can say, all right, so I want the cosine inverse of -1. That means, when is cosine -1? Cosine is -1 at pi. And then when is cosine 0? Cosine is 0 at pi halves. And when is cosine 1? Cosine is 1 at 0. So then this is what cosine inverse looks like as a graph. So when we find the inverse values, based on the values we already know, positive ones are still coming from the first quadrant, because they always do. But I can't get my negative ones from the fourth quadrant, because cosine's still positive in the fourth quadrant. So instead, I'm going from 0 to pi. It's quadrants 1 and 2 for cosine. Okay, so if we look at sine and cosine together, you can see that your inputs are still going to be the same. It's still going to be from -1 to 1, because they have all the same values, just in different orders. But my output for sine is from quadrants 1 and 4. My outputs for cosine are from quadrants 1 and 2, because that's the only way I get my negative values. Okay, we okay so far? Maybe. Maybe when we actually start finding them, it'll make a little bit more sense. All right, so let's look at tangent real quick, and then we'll start finding them. So arctangent, or tangent inverse, sketch a little graph here. And so tangent, just quickly would look something like this. Okay. So if I want a section of that graph that would pass the horizontal line test, I can just pick any one of those little repetitive sections, but we want the ones as close to 0 as possible. So this is the part we're going to use, which makes tangent kind of nice there. And that goes from -pi halves to pi halves. That's why it's restricted that way. So when the angle is -pi halves, tangent is undefined. And when it's pi halves, tangent is undefined. That's old business. When the angle is pi fourths, tangent is 1. When the angle is 0, tangent is 0. When the angle is -pi fourths, it's -1. So this is the section that we actually get to have an inverse for. Our restricted domain goes from -pi halves to pi halves. Do I get to include them this time? No, because there are asymptotes there. And then since it keeps going, your range is actually from -infinity to infinity. For the inverse, those exchange places. So we get -infinity to infinity. And then our range is -pi halves to pi halves. So then we're asking the questions backwards. Instead of saying, what is the tangent of pi fourths, I'm going to say, when is tangent 1? Tangent is 1 when the angle is pi fourths. Yes. Tangent is 0 at 0. Tangent is -1 at -pi4. And then now we have horizontal asymptotes like so. Yes, but so when inverse, it's always a reflection in the line y equals x. So it's kind of, if it lays down, if it reflects as it lays down, then you're good. So what we're doing with these inverses, this analogy seemed to help somebody last period that was struggling as we went through it, so I'll try and start y'all with it. If I say, what is 2 times 5, and you tell me it's 10, right? So that's like, what is the cosine of pi thirds? And you give me the answer. So the inverse would be kind of like 10 divided by 5 equals 2, or you can think of it as 2 times x equals 10. So like 2 times what gives me 10? That's, I think, a good way to think about these, because I don't expect you necessarily just to have the inverses memorized. As far as the other values, you should come up with those pretty quickly. If you don't know your values forwards, it's going to be really hard to do it backwards. But if you know them going forwards, then thinking about it like this, it's just like a number family. The 3 things go together. You just have to, we're just talking about them in a different order. So instead of saying, what is the tangent of pi4? It's 1. We'll say, well, when is tangent 1? Tangent is 1 at pi4. It's just a different order of the same values that go together. Okay? Maybe? Okay. Let's look at a few. There's only one little thing that really kind of makes this confusing, and that's just keeping up with what values you actually get to give. So if we have arc sine, those answers are coming from quadrants 1 and 4. And not only that, but it has to be between negative pi halves and pi halves. That means that if you think your answer is 7 pi4, because you figured it out, you go, oh, it's right here, so it's got to be 7 pi4. 7 pi4 is not an acceptable answer because it's not between negative pi halves and pi halves. So instead, the other way to get there would be negative pi4. Does that make sense? Even though you're at the same spot, you have to have your values between those two numbers. Okay? Then for arc cosine, these are coming from quadrants 1 and 2. We're going from 0 to pi. And arctangent and arcsine go together, so arctangent is also quadrants 1 and 4, going from negative pi halves to pi halves. Okay. And here's what I mean by making sure you fits into those values. Right, so I'm going to do a little example over here first. If I asked you for the sine of 7 pi 6, so this is not an inverse one. This is just an old one, like a question I'd ask you at the door. What is the sine of 7 pi 6? So the first thing I would think is, all right, so for pi 6, sine is 1/2. So I know it's either 1/2 or negative 1/2. Then I ask myself, what quadrant is 7 pi 6 in? What quadrant is that? Third. And in the third quadrant, is sine positive or negative? And the third quadrant is sine positive or negative? Negative. So this would be negative 1/2. Okay? So that's, again, old business, old kind of question. Hopefully we all agree with that statement, right? So remember I said, if I have 2 times 5, that equals 10. So 10 divided by 5 equals 2. That's not necessarily the case here exactly. Okay, meaning that if I then said, all right, well now I want the sine inverse of negative 1/2. Going to go the other way, right? Sine inverse of negative 1/2 does not equal 7 pi 6. You can't just take it directly backwards, because 7 pi 6 does not fit between negative pi halves and pi halves. You have to think about your domain and range that you have. Now, this value will give me that negative 1/2, but when I'm going that direction, when I actually want the sine inverse of negative 1/2, I can still use my hand trick, okay? Cosine's on the left, sine's on the right. So when sine is 1/2, this is my angle. It's still a pi 6th angle. And so it's either pi 6th, or since it's got to get my negative angles, it would actually be negative pi 6. So here's the thing. There are an infinite amount of angles that will give me a sine value of -1/2. Okay? 2 just on between 0 and 2 pi, because there's 2 quadrants where it could be negative. And I could keep going. There's an infinite amount of them. Sine of an infinite number of different things will give me -1/2. But when I take the inverse, there is exactly one answer, okay, because of that limited domain. Does that help a little bit on what we're being picky on? The good news is, if you're going to take the inverse of a positive value, it's all from the first quadrant. None of those are confusing at all. All right? But then here's the thing. When you have a negative value you're taking the inverse of, if it's a cosine, you have to think of a second quadrant angle. When it's sine or tangent, those are pretty easy too, because it's whatever that first quadrant angle is, you just make it negative, because all you're doing is going the opposite direction. So they're not that complicated. You just have to make sure you can wrap your mind around why you can't do stuff like this. Okay? So let's work through some of these, and hopefully you'll see it's really not that bad. All right, so let's start with the arc sine of 1. So what I ask myself is, when is sine 1? So when is the sine value 1? At what angle? Okay, and again, you can picture the unit circle, not the other graphs. Sine is 1 where? Pi halves, right? And sometimes it helps just to have like a little cross, or, I do this more so than a circle because my circles never look like circles, but I can then think around the circle. Okay, so sine is 0 here, this is sine is 1, that's at pi halves. Does that make sense? That's my answer. All right, sine inverse of the square root of 3 over 2. Again, you can use your hand trick. Sine, this is when sine is the square root of 3 over 2. So what's this angle? Pi thirds. So my answer is just pi thirds. If you know your values going forwards very well, then going backwards is not that big of a deal. All right? Arc sine of -2. So when is sine -2? Is it ever -2? No, it's not. Because your domain, your input can only go from -1 to 1. So this isn't even an allowable input, so this just does not exist. No. All right, so cosine inverse of -square root of 2 over 2. Okay, so you can think through the positive ones first. That's the thought process my brain goes through. Think, okay, so cosine of, when cosine is square root of 2 over 2, I'm at which angle? Pi fourths, okay? But this is negative, so I know it's not pi fourths, but it's a pi fourths angle, right? And so since this is cosine, am I going to have a negative pi fourths, or do I have to go to the second quadrant? Second quadrant. You are not going to have a negative answer for any of the cosine ones. So this will be a positive something. It's a pi fourths angle, but it's my second quadrant pi fourths angle, which is what? 3 pi fourths. Right. Okay, so then what do you think about cosine inverse of 3? Does not exist. Good. All right. So then what do we think about arc cosine of -1? That means when is the cosine value -1? At what angle? Remember if you have your little thing? Okay. Cosine is 1 here, it's 0 here, it's -1 here, and that is at pi. Okay. Your answers here are angles, not values, because it's the opposite. Okay? Any questions at this point? All right, so I'm going to give you a minute. I want you to think through 7, 8, and 9. Just think through them on your own, and then we'll talk through them together. I'm not going to call anybody out, call anybody just yet. Let's make sure we get it. let's look at number 7. I actually think tangent going backwards is a little easier because then you can see how many 3's you have. So the arctangent of the square root of 3 over 3 would be, it's positive because we're going to be in the first quadrant, positive pi what? 6th? Yeah. 2 3's with a tangent give you a 6. All right, so then arctangent of negative 1. So tangent, when is tangent positive 1? At what angle? Pi fourths. Okay, so it's positive 1 at pi fourths. This is negative 1 in its tangent, so that means it's just negative pi fourths. Okay? If you have a negative value, you'll have a negative angle for sine and tangent, but for cosine, it'll be a second quadrant angle. All right, so then tangent inverse of the square root of 3, what's that going to be? Pi thirds, right? Okay. All right, so I'll give you a minute for 10, 11, and 12. All right, so arc cosine of negative square root of 3 over 2. So let's think through the positive. Positive square root of 3 over 2 for cosine, if I'm using my hand trick, this is where my square root of 3 over 2 for cosine would be, which means my angle is pi 6. But this is negative, and it's cosine, so I go to which quadrant? The second. And my second quadrant, pi 6th angle is 5 pi 6ths. Do we agree with that? See how that works? Okay. So tangent inverse of 1, what's that? Just pi fourths, right? Those match up right there. All right, so then arc sine of negative square root of 2 over 2. All right, so when is sine square root of 2 over 2? Positive. Pi fourths, right? So it's at pi fourths, but since this is a negative value, that means this one's going to be a negative pi fourths. So look at this one, number 12, compared to number 4. Because sine and cosine have the same value at pi fourths. It's square root of 2 over 2. But when you take it negative, and we take in the inverse, sine has to go to the fourth quadrant, cosine goes to the second quadrant. Okay, are we good? All right, so you do the last 6. And I'm going to let you help me. Okay, so sine inverse of negative 1/2. Trent, what is the sine inverse of negative 1/2?
I got negative 1/2.
It is negative 1/2. Okay, think about what you just said, because I want the sine inverse of negative 1/2. It's not negative 1/2. What is it? It has to be an angle, sweetheart. So when is sine positive 1, or when is sine positive 1/2? What angle value for a positive 1/2?
45 degrees? No, 30 degrees.
Oh, you talking to me in degrees? What's in radians? We hadn't talked about degrees in a long time.
true.
True, yeah.
It's pi over 6.
Okay, so it's pi 6, good. So then since this is a negative 1/2 and it's sine, do I go to the second quadrant or the fourth quadrant?
The fourth quadrant.
Okay, and so then what would my answer be?
Negative 11/6.
Negative 11/6 actually puts me in the first quadrant. If you think about that, because go all the way around. So it's just negative what?
So it's be 11.
Okay, can't be 11 pi 6 because for pi, or for sine, you have to be between negative pi halves and pi halves. Right? So what angle, 11 pi 6, I mean, yeah, the sine of 11 pi 6 is negative 1/2, but the sine inverse of negative 1/2 has only one right answer. What would that be? Negative what? How else can I get to that same spot? 11 pi 6 puts me right here. How else can I get there where I would be between negative pi halves and pi halves? How did we get there on all the other ones we just did? Somebody want to help him? What is it? Negative pi 6. That's all it is. Once you get the positive one, it's just negative. Okay? All right, thank you. So arc cosine of 2. Kaylee, what's that? Does not exist. You're right, with a question mark on the end. I love when y'all answer me with question marks. Does not exist. All right. Yes, you're right, because you can only go from negative 1 to 1. Good. All right, so then arctangent of negative square root of 3. Dylan, what's that? I'm sorry, the arctangent of negative square root of 3. I don't know what just came out of my mouth, but answer number 15. Not whatever I just said.
Negative pi over 3.
Yes, sir, negative pi over 3. Thank you. All right, sine inverse of 1/2. Jake Cruz, what's that? Pi over 6. Good deal. All right. Now arctangent of negative square root of 3 over 3. Jesus, what's that?
Negative pi over 6.
You got it. Thank you. And then cosine inverse of negative 1/2. Vanessa, what's that? Negative pi over 3. Okay, so it's cosine. So you're right, it's a pi thirds angle. But for cosine, do I go to the fourth quadrant? Which quadrant do I go to for cosine? I have to go to the second quadrant, right? So what's my second quadrant pi thirds angle then? Huh? Okay, well, just think about it. Count around. So when you don't remember, okay, because you're not going to be the only ones being like, oh, I don't remember. You're here, you know you got pi thirds, right? But you need the second quadrant pi thirds angle. Remember that here, this is pi, which is the same as 3 pi thirds, right? So this is 1 pi thirds, that's 3 pi thirds. What has to go in here? 2 pi thirds when you're counting them. That makes sense? So 3 pi thirds, you back up 1, and you're going to get 2 pi thirds. Does that make sense? Yes? Okay. Any questions about any of those? Do you understand how those are, you have to think differently for the different ones, yes? Okay, good deal. All right, so let's look at a quick application of this. We're going to apply these a little bit later on after we get some more stuff under our belts and start solving things, but here's just a quick one. It says, a ship left port A and sailed 60 miles due east to port B. From port B, the ship sailed 120 miles northwest and stopped directly north of port A. Find the bearing from port B to the current location of the ship. All right, so here's port A. I'm going to sail 60 miles due east to port B. So there's my 60 miles. Then from port B, we're going to go northwest and stop due north of point A, or port A. So that makes this as a right angle. That's why that due north is important, because it's right above it. This was 120 miles. Right? And then I want the bearing from port B to where this is now. So the bearing, like here's my little compass here. This is what would actually give me the bearing. It's not in my triangle, but I can find this angle, and then that would help me with the bearing. Okay. So since I have a right triangle, and I have two sides that I know, and I'm looking for an angle, it's just simple right triangle trig. So with this angle, this is my adjacent side. This is my hypotenuse. Which trig function uses adjacent and hypotenuse? Sine, cosine, or tangent? It's cosine. So the cosine of theta equals the adjacent, which is 60, over the hypotenuse, which is 120. So then you can take we're trying to get theta by itself, so I'm going to take the cosine inverse of both sides. So I'll get theta equals the cosine inverse, and then 60 over 120 will reduce to 1/2. So we can figure out what the cosine inverse of 1/2 is. Cosine inverse of 1/2, we've got this angle right here, which is what angle? Pi thirds. Okay, so it's pi thirds, and in this case, pi thirds should be the first thing you think about. You absolutely have to be able to think in radians. Like, we shouldn't be really thinking in degrees at all anymore, because that will not help you in calculus, like, at all. But then I do need to know the basic ones, like, what is this in degrees? This would be how many degrees? And that would be a 60. It would be 60 degrees. So this is 60 degrees. But this is the angle I really want, which is 30 degrees. And the reason I have to change is because when we talk about bearing, we talk in terms of degrees. We don't talk in terms of radians. So then I can say the bearing is north 30 degrees west. That's just a super basic example of where you would use inverses. So then let's look at 11. 11 says the angle of elevation from a football on the football field to the crossbar on the goalpost depends on d, the distance from the ball to the base of the goalpost. Write theta as a function of d. So that means I'm going to have a theta equals something. So I have to make some sense of this. Here's my angle. I have the adjacent side and I have the opposite side, and I have a right triangle again. So opposite and adjacent is tangent. So I can write out that the tangent of theta equals the opposite, which is 10, over the adjacent, which is d. To get theta by itself, I would have to take the tangent inverse of both sides. So then that means that theta is equal to the tangent inverse of 10 over d. So this is theta as a function of the distance. We're not solving for anything because we don't have enough information, but at this point I could put in different distances, and then that would tell me what my angle would have to be. Okay, just a way to look at it as a function. Okay, any questions at all? We good? Okay, so let me remind you that could you get these values that we just went through by thinking in our heads? Could we get those by pushing buttons on a calculator? Yeah, you actually could. But that's not how you're going to need to use them, and so that can't be the way that you learn them. So if that's the only way you're going to be able to come up with these things, that is a bad, bad thing. Okay, you're only going to get out of this class what you put into it. I'm giving you everything you need. Unfortunately, I can't force you down certain roads just by the nature of how school is this year. So I'm just reminding you once again that you absolutely have to practice this stuff on your own in order for you to be able to get out of it what you need. Okay? Any questions at all?